Dear students, so far we have discussed about the chemistry, sources of gums as a group of compounds. We have also considered their applications in food for different purposes. Now, let us know more about gum arabic, which is commonly called as khera gum and that is most commonly used as the household gum. It is derived from Acacia senegal or commonly known as kher tree. A sial tree commonly found in tropical and subtropical countries, especially in Africa and in India. Joint Expert Committee for Food Additives define it as a dried exudate obtained from the stems of Acacia senegal and closely related species of Acacia family. Chemistry. Now, while considering the chemistry of gum arabic, it's a branched chain polysaccharide having a very high molecular weight, approximately 350 to 850 kD. The chain consists of galactose, rhamnose, glucuronic acid and arabinose residues, and it also contains minerals like calcium, potassium and magnesium. The total amount of protein is less than 3%. Gum arabic is composed of around 39 to 42% of galactose, 24 to 27% of arabinose, 12 to 16% rhamnose, 15 to 16% glucuronic acid and its derivatives, and 1.5 to 2.6% of proteins, 0.22 to 0.39% nitrogen and around 12.5 to 16% moisture. The chemical composition of the gum differs from its source, the age of source of the tree and the soil conditions as well as the climate. The main structure consists of a 1,3 beta-D-galactopyranosyl units as a backbone. There are side chains which are composed of 2 to 5 1,3 linked beta-D-galactopyranosyl units which are joined to the main chain by 1,6 linkages. Both the main and the side chains contain dispersed units of alpha-L arabinofuranosyl, alpha-L rhamnofuranosyl units and also beta-D glucanopyranosyl and 4-methoxy beta-D glucuronopyranosyl residues. The last two mostly are present as end units. Now, let us talk about the physicochemical characteristics of gum arabic. Gum arabic is a colorless, odorless, tasteless substance, and thus it does not affect the odor, color and the taste when it is added to any food substance. It's highly soluble in water. It can dissolve up to 50% concentration in cold as well as hot water. The solution exhibits Newtonian behavior at concentrations up to 40%, but beyond that the solution becomes pseudoplastic. The viscosity of the solution again varies with the type of gum arabic and also with the pH and the ionic strength. Maximum viscosity is observed between pH 6 to 7 and therefore this viscous solution acts as a protective colloid and a natural emulsifier. Despite the fact that gum arabic is widely used as a vehicle for drugs in experimental physiological and pharmacological experiments and is assumed to be an inert substance, some recent reports have shown that gum arabic possesses antioxidant nephroprotective effect. Now, talking about pharmacological properties of gum arabic. The most important therapeutic application of gum arabic is as a probiotic. This is due to the relative inaccessibility to various digestive enzymes. It is a non-digestible ingredient that can beneficially affect the host gut by selectively stimulating the growth of gut microbiota without stimulating colonization of unwanted bacteria, and thus it contributes to good health. Studies have suggested its potential usage as prebiotic. Studies in human volunteers have indicated that regular consumption of fixed quantity of gum arabic by human volunteers led to significant increase in the number of bacteroids and bifidobacterium in the gut. Similarly, the consumption of 10 to 15 grams of gum arabic for 10 days yielded an increase in the colonies of lactic acid producing bacteria and bifidobacterium in the fecal samples as well. Moreover, gum arabic is already used as a coating agent in food industry, and it is known to step up the survival of probiotic factors in the gut. Thus, gum arabic enhances prebiotic functionality in healthy human subjects, which is dose dependent. Potential functionality of gum arabic on gastrointestinal health is underlined by its effect on production of short chain fatty acids, in vitro, and enhancement of gut membrane function. Maximizing the host resistance in the intestine is another biological function associated with consumption of gum arabic. This has been reported in several experimental animals. Gum arabic has gelling properties, and therefore it can be used as an diarrhea to hold the moisture and give a corrective effect. All these factors are promising that the gum arabic is potentially an interesting substance for gut health and efficiency. Apart from the gut health, gums have a possible effect of lowering glycemic index, and hence they can be useful in diabetes. Although scientific studies are needed, some reports are available. In case of renal function, clinically it has been tested in patients with chronic renal disease, and it is claimed to help in reduction of serum urea and reduction of creatinine, thus minimizing the frequency of dialysis from 3 to 2 times per week. It is also reported to have antioxidant activity. It is potentially viewed as an antioxidant which could protect against experimental hepatic, renal and cardiac toxicities in rats, but these studies were limited. Gum arabic has been claimed to minimize the harmful effect in chronic renal diseases in humans, although experimental evidence in case of humans is lacking. Effect of gum arabic on oxidative stress and inflammation in adenine-induced chronic renal failure in rats has been studied. It was indicated that adenine significantly increased the concentration of serum urea and creatinine. It decreased the creatinine clearance, and therefore it indicated notable increase in concentration of inflammatory markers. Further, it also showed oxidative stress and DNA damage. But treatment with gum arabic indicated a positive effect on these actions. Regarding lipid metabolism, reports on effect of gum arabic on lipid metabolism in humans and rats are varied, but they suggest that gum arabic consumption can decrease the serum values of cholesterol in rats. As far as oral health is concerned, it enhances dental remineralization and has some antimicrobial activity as well. Therefore, it suggests its potential used in the field of dentistry. In folk medicine, gum arabic has been reported to be used orally for treating the inflammation of the oral cavity, intestinal mucosa, and externally to cover the inflamed body areas. However, in certain cases, gum arabic has been shown to have an adverse effect on electrolytic balance and vitamin levels in mice, and is also known to cause hypersensitivity in humans. So, friends, thus we have seen the pharmacological and physiological aspects of various gums with specific studies on gum arabic. We have also seen their potential applications as food additives, and therefore this all information will help you to realize the importance of gums in foods.